So we are recording now, and I want to point out what I am currently focusing on is the AWS architecture illustrations. And in there, you will find one of the things that I did mention, and I'll remind you for what I'm talking about, is let me give you the link. It's easier. I'm pasting a link in chat window. And in there, you will find that I am focusing on one of these drawings, and that is the media sharing, this item, which is also available to me in my notepad here on the on this window here. That's what I have. And so I will be quickly recapping what we discussed the other day, and then continue forward with the remainder discussion and finish the Netflix case is the plan. So if you remember and recall, the idea behind the company Netflix is to create the entire business of getting the end user to be able to successfully watch their videos. That's the primary idea, right? So I will open another sheet here actually, so it helped me draw. So another sheet and open in a new window like that on this side, and this window goes on the other side. Now we have two windows side by side. That will help. And fit width. Okay, that should be useful now. So if you remember and recall, the goal of this business is to get movies from raw sources. It's too thick. So raw material from wherever it comes from, like Hollywood, mostly Hollywood. Sometimes they make their own, like House of Cards is internally created. So the sources come from variety of places, and those are raw video files, raw files. They are very large. They need to be converted into a format that fits the target device, the target devices. There are a variety of different types from various companies. Like that, Sony and others. And so variety of different device types are available, and each of them has different codecs, different resolution, and a bunch of other details that everybody knows. So for every movie, we were talking about a movie called what was it, Bohemian Rhapsody. That's the movie. We were talking about that, and what we were doing is understanding how will the workflow about taking this movie from the source and then making sure that it becomes available to these users on a variety of devices on a deadline that they will agree with the sources, like the people who make this movie, for example. And so like this movie, there are probably a million other movies, on the long tail. So they have to be processing each and every movie for each and every supported device. So that's the work of processing. It involves transcoding, basically. Transcoding. This transcoding action is predominantly done using this library called FFmpeg. That's the name of the library used, and it needs to be running on the processing pipeline. These machines need to run that. That's the primary idea we were discussing the other day. In this screen, you will see, this processing pipeline will run these machines collectively, will auto scale and run the processing of this movie called Bohemian Rhapsody sitting here in the raw form, and corresponding entry to that is actually probably available to us, or rather the machines out here. These machines have access to a queue. I think this queue idea may be confusing if you haven't heard me describe it. But that's basically something that I would like to briefly tell you so that you don't get led behind in our further discussion. So what I'm telling you is the idea here. And let me describe this queue idea. If you are not familiar with this, I would like to spend a few minutes on talking about that so that you don't get confused about what that queue was supposed to be doing. And so the idea is that we have this movie here and a corresponding entry in this queue. But what is queue? So let's go understand that piece. So queue is basically a to-do list, a list of things to do. And that queue will contain items. They are called to-do list items. One of the items will be to take this movie, which is sitting here in its raw format. Where is it sitting? Right here. And so that movie needs to be taken and needs to be made sure that it gets processed. And the first action for to-do list item is to process it for this device, for that codec, for that resolution, for Microsoft Xbox. Let's make stuff up right now. So that's the item number one. The next item is for the same movie. Do it for Apple iPhone, iPhone 4S, which has a different resolution than the 10XS. So variety of devices. We'll have to have one item for converting, transcoding a given movie for each of these target devices. So lots of to-do items here. They are all sitting in the queue, which is a product called Simple Queuing Service. It is available in Amazon. You can create your own. It actually uses a product called RabbitMQ. There are other queuing solutions in the open source. RabbitMQ is one of them that is used, and you can create a queuing solution very easily by using a ready-made Docker image like this one, for example. So it's a very easy to implement solution. It is also available as a service. The service is pretty darn cheap. It's called Simple Queuing Service. That's what it gives you, is a ready-made to-do list. And in that to-do list, you will have things like I just mentioned, which is, hey, let us convert this movie, incoming movie, into an output for all these devices, and put this output where it belongs, meaning it needs to go right next to this movie. So here is your iPhone format. Here is your Xbox format. Here is your other file devices format converted and ready to go for this movie. And so they will all go back into this bucket. So now the flow of the pipe, let's understand the flow. The flow is coming from here. And these robots or these people that belong to the Netflix company, they will take that movie raw sources from Bollywood, from here, and then upload it into a load balancer, which will automatically, of course, balance the load among multiple upload servers. This scenario will scale out, scale in, depending on how many movies are coming in, and it will grow and shrink, and the movies will be uploaded into a bucket. That's where it will sit. But as soon as the movie is uploaded, a corresponding list of items goes in the to-do list. And then this function is done. Basically, that portion is taken care of. So the next action is to make sure that those movies are processed. And that's where the other segment comes into play. In that segment, what it does is looks at this queue and say, hey, what do I have? And let me process the queue. And so that processing of the queue happens primarily with the idea that we will be using that segment of the processing pipeline to process the items we have in our queue. And so to enable that, what we do is use these machines. They are collectively also in an auto-scaling group, meaning they will also grow and shrink. And you will have more machines coming in depending on a trigger. And we discussed about the trigger being just something that is relevant to this issue of processing the videos sitting here, and a queue item corresponding to the Bohemian Rhapsody movie being converted into a variety of device formats. Those are the queue items. We need to process them. That's where this whole stack of machines come into play. In an auto-scaling group, they will look at the queue length and trigger. If the length is higher than a certain number, then it will trigger one more box, something like that. One more box gets added to this collection, so that it will then take on this next item, to-do list item, and start processing it. A couple of ideas that I think I covered, which are, I think it's best to watch the recording. but I'll give you a brief highlight about what I did cover about the processing pipeline. In that, the idea here is that it is not really a critical thing all the time. It is not critical, meaning it is not something that needs to be happen like right away. It can happen whenever it needs to happen. It doesn't need to happen right away. That's the nature of the particular work item there, because that's how the business requires. And I'll describe what I mean by that. So we have this Bohemian Rhapsody movie just came out. Now it doesn't going to become available immediately. Maybe roughly about takes 8 to 16 weeks for that movie to become available on the Netflix service. That's estimated time. So I'm just making up a date of February 15th on which that movie will become here. So they have enough time. They have the raw files right now available to them. They have enough time between now and that date to finish the processing of that one particular movie. And so that's where you will find that this job is not highly critical to be finished like right now, which means they can go cheaper route. And that's the underlying idea here, which is the concept of a spot instance. Those machines are slightly cheaper compared to the other machine type like we've been discussing. Roughly speaking, they're about 67% discounted, give or take. The prices are dynamic. And I think it's best to understand the ideas behind the concept of the 3 different types of pricing in Amazon. Is one that you already know, that you want a machine, you pay the price. It's called on demand. And you typically pay something like $100, 100 cents, or some number. It's a relative number here right now. So relative pricing. Here you will go spot pricing. That will be basically based on market demand. The typical prices you will probably pay will be like 30, relatively speaking, give or take. This number is fluctuating number. It fluctuates based on market forces. Users asking for more will jack up the price, and users not asking for more will reduce the price. It's dynamic. And I think we covered those ideas in quite a bit depth in the other video and the other last session. So you should pay attention to that. It's a business discussion about pricing, about when you should use these kind of machines. And then there is a third type also called, what's the name Amazon uses? I call it contracted price. So contracted. Amazon's name, I think, is called, forgetting the name, what Amazon uses. The name should be here. What do they call it? Let's say compute. I think they're called they're called reserved instances. So that's the item, reserved. The item is called reserved instances, which basically means you pay for the amount of money at a set price for a long period of time, like for 3 years. And then you decide to pay that. I will pay you 45 cents for 3 years every hour. And then that's the contracted price. There is an interesting way to look at the usage model of these, and that is in on demand. You have the ability, you can kill the machine anytime you feel like. And in spot price, Bezos can kill the machine anytime. And the third one is, the small contracted price, which is no one can kill the machine for 3 years. That's the kind of pricing model you should, it's a quick way to think about. Contracted price is how you can kill it anytime you feel like. It's on demand. You shoot the cow is dead. That's the idea. And you pay a lot more money for that privilege to kill anytime you feel like. And here, spot machines, you may not want to kill, but of course you can kill. But Bezos can also kill anytime. And so you have the ability to get a machine roughly about cheaper price. Sometimes it's 33, sometimes it's 30, depending on what the pricing is. But Bezos can also kill. You can also obviously kill. And here, no one can kill. No, you cannot kill, Bezos cannot kill. You're a commitment for 3 year long contracted price. You pay 45 cents. And that's the idea behind these 3 types of prices. So the core concept here is Use cheap machines whenever there is a non-critical scenario. Sometimes this scenario is not critical. Like, for example, we have enough time between the movie right now and the date on which it becomes available on Netflix. There is ample time. So use cheap machines like these guys. That's the idea here. Spot instances. But sometimes, the idea is not that possible. So you actually go end up spending either on demand or other types of machines to get the work done, and you move on. So when the work is done, we have to understand what does that done mean, because it is not actually done. So let's go understand what does done mean in the context of this discussion. So technically, the done means that a user wanted to watch this movie on that day. This movie, this Bohemian Rhapsody movie on this day on Netflix, they should be able to watch it. That's when I call it done. For right now, I am just referring to the portion of processing of that video as done, which means that movie, which was sitting here raw, is now processed based on these machines operating, and now we have processed files also available here in the same bucket, and the queue is empty. That means these machines can be killed and they'll automatically die because the queue is empty. And so there are no machines there. The moment you have new movies coming into the pipe like this, going uploaded to the upload servers, here, goes here, and then you put a new work item here in the to-do list, the machine will kickstart. And as a consequence, it will start processing something. And then when it processes and it finishes the processing finishes the new movie called N, new movie. That new movie sits here, and the corresponding output becomes also available alongside. The processing is happening here. When it finishes the processing, it will put the processed output also right next to the original movie. And then this item is empty again. So that's the idea of processing pipeline. So the movies and its produced device-specific output, all of them are sitting right here. But that doesn't make the user happy quite yet. So now let us divide this picture that we have at our hand into, roughly speaking, two parts. And actually, it's already divided. If you pay careful attention, you can see that there are these dark colored boxes. These boxes are kind of dark colored, whereas the other ones are light colored boxes. So I'll now highlight to you the other boxes. These are these boxes. They are kind of light colored. And this is kind of shared in between. So if you look at this segment now, we will go and understand what these segments will do for us. And this segment, I call it the user-facing portion of media sharing design. This segment is the processing. This is the upload portion. And now we will understand the other perspective. Now we will look at this person again. This person in our initial discussions was an employee of Netflix, or most likely a robot of Netflix. That is basically taking these raw materials and uploading into the load balancer, into auto scaling upload web servers, and that gets stored here and the processing finished. So that's the robot, or maybe an employee at Netflix company is doing. Now we will look at the same scenario, but with this person being a person like you and me, like it is, viewers or customers, customer of Netflix. So now we come to the point where we are now going to look at this person. He or she may open a Netflix browser, or a browser pointing to the netflix.com website. Now, the moment this person, he is probably not a robot, he or she is a person. They're paying money to enjoy the experience that Netflix provides. And that person is, they have access to a lot of devices in their home, and so they want to open up any device anytime they feel like. And the first time they go open a browser, they will not be presented with what you expect to see in the movies. So this Bohemian Rhapsody movie, the other movie, they're not directly visible to this guy right away. They have to go through what is called paywall. A paywall is basically like a fire wall. You have to go through some trouble to get to the other side. And this trouble can be, rejected. You may not be allowed, provided you meet certain conditions. And so the idea of a paywall is basically that you can go through the paywall provided you pay. Otherwise, you're rejected. That's the simple idea of a paywall. And that's very common in most cases where you are a customer, log on to Netflix website. You typically are not shown the movie right away because Netflix wants you to pay. And so they send you to a different site that is not shown in this picture, not here. And that site is your sales and marketing site, where you will register for an account and you put a credit card, and basically you sign up a money contract. I'll pay you so much every month and you let me in. That's the contract. It's business site. And that's where they will show whatever you see when you see the Netflix without login. Like, go to the Netflix site and you say Netflix and you don't have a login. That whatever you see is a sales and marketing site. Here, join for a free month. Okay, choose your plan. That's business, right? The basic standard, whatever these plans are. So that's, you already know, but I'm just pointing out to you that this is not this infrastructure. It's a separate site focused on business, basically focused on collecting money. That is what, oops. That is what you see here. So sign in, choose your plan. They give you some advertisement, sometimes give you a 1 month off, a no commitment, see some pictures, maybe some links, FAQ, questions, phone number. Oh, there's a phone number. So that's the idea. But we are not talking about this site. We are talking about something that we see after we sign in. And that you already know, you've seen it. That's what I'm talking about, after the sign-in experience. That experience is not on the sales and marketing side, but the customer service delivery side. So this customer now is looking after the login. So customer, first thing, they log in, they either sign up, but I'm just skipping the sales marketing discussion completely altogether. So this is before login. That is a separate site. It has something to do with collect money. Once you have money, then you go to after login. So this segment, whatever the customer will see, is after login. They paid money, now they want to access the service delivery components will come into play, and that's where this person will want to watch what they expect to see. And that's what this person will do, is go and hit a load balancer. And this is not just one or two with the millions of customers. So this is probably a very heavily busy load balancer, which is auto scaling, because it is looking at how many people are actually waiting to get access to the content from the web servers. And then these guys, they will ask for whatever they want to access, meaning, the iPhone opens up, goes to the Netflix app. Netflix app will basically connect to the same point. It is this point. Every device, Xbox, you start, it goes and hits here. iPhone app, you start, goes and hits here. Firefox browser hits there. Whatever you have, Nintendo consoles, they also hit the same destination, which is the elastic load balancing front end. Then it translates all this incoming traffic into one of these boxes. And there need to be a lot of web servers to handle that. Incoming traffic of millions of customers coming in, they need to be served. And those web servers are basically be the entity responsible to show the experience that people get after login. Now these web servers need to scale, auto scaling. This little triangular thing that you see is the idea that Amazon makes you believe that this is an auto scaling group. And we'll actually do a live example of what an auto scaling group is and what are the triggers that you need to be putting in place. And we'll take a fictitious example and make it real. So you can actually understand and appreciate the idea of an auto scaling group as to how do we trigger, how do we make it grow, how do we make it shrink. And I'll do that exercise live so that you will really understand how exactly this auto scaling group thing works out. So we'll actually experiment with this in a few minutes, maybe after at some point today. So clearing this and focusing on the other ideas behind what the user sees. So the user looks at one such box. That box will actually paint the same experience that you see when you visit and log in. And you already know that. So I'm just logging in. I hope it doesn't make noise. This thing should not make some, it starts to play like random videos without asking for permission, which is not what I want. And so I hope it doesn't make noise. It does. So I'm going to mute it. Okay, there we go. So what you're looking at is just the collection of movies available from Netflix, right? You've already seen this. And what you are also looking at is, for example, let's pick some House of Cards. There is House of Cards right there. So this House of Cards is something that you see the picture itself of House of Cards. That picture is called information about the item. So there is this movie, or rather House of Cards, movie or serial or God knows what, that video, let's call it a video. That video exists. Now, in addition to that video file itself, which is probably sitting somewhere here in the bucket, somewhere. You don't exactly know which bucket, but there is House of Cards sitting here. And it's converted into all the device formats that we expect. And currently I am using a browser. So that House of Cards video will be correctly picked up based on my machine, Safari browser in this machine, and will automatically start to deliver when I press the play button. I haven't pressed it yet. But in addition to that video, there are lots of other details that are necessary to be provided to the end user so that they can make a conscious decision on whether or not they actually want to play that thing. And so that data about the video, I would call it metadata. And you can see that metadata right here, for example. And this is where you can find IMDb is a place to go find the metadata. Now, you can actually, by the way, find the metadata right here also. But I am not clicking on those buttons because the moment I click the play button, it starts to play the video and we are recording. And so that becomes a copyright violation. I don't want to violate copyright, so I'm not clicking and showing you the metadata here, but instead I'm showing you the same metadata in another site, which is public. So here you can see that you can actually search for some movie, like a video called House of Cards. I hope that is available here, I guess. House of Cards. Yeah, it is there. And so see that detail about House of Cards, whatever this thing is. And you see the item, the ratings, the duration, drama, TV series, dates. We have 73 episodes. And then the people who play, the creator, the stars, and reviews, and basically information about the show itself. Which means we are looking at not just the video, but also information about the video. And this is called metadata. Metadata. It's the data about this data. So this is the data, and this is the metadata. So this data is about this. So there is information about all the details that you see in IMDb, for example, like here. And so that detail, and you can further go and understand trivia, user reviews, and a bunch of other related details that I think you already understand. So that detail is also stored alongside this video, and it is sitting right in that bucket, along with all the converted video formats. And this is, by the way, collected by the Netflix company, if not created by the Netflix company, and put in alongside every single video. That is what is picked up, not the video itself, but just the data about the data, the metadata is picked up by these servers and is given to you. when you go visit this website right here. And so that's what you're looking at here. And I'm not playing it for a reason I told you already. And so that's what the user is seeing, and that representation is coming from this machine, one that was allocated to this user by the load balancer. And there are millions and millions of such users who are trying to access some of these machines, and they're basically presented with a view like this. Here you can make a selection or search for my favorite movie, which is, I'm so bummed that it is not here, but that's not the point. So there is this movie that I wanted to see, it's not there, but yeah, whatever. So the point being that you are actually experiencing the metadata when you begin. And then when you zoom in on one particular movie, like I want to see, let's say, where is that? What? I know some movie, let's go home, and the first movie I'll see, that's the movie. The Outlaw King, that's the one I want to watch. So fine. Outlaw King, that's the name of the movie. So I click the play button on that movie, and now something happens that you should now observe. What will happen at that moment is, as soon as you select a particular movie, like this OK movie that I picked up, which was called, what was that? Called Outlaw King. Outlaw King. So I pick up Outlaw King, and what it will do is now hand off control. The control handoff happens like this. There is this Outlaw King movie sitting here. It is sitting for a variety of devices. There is corresponding metadata available here, all in the bucket. Now this user decides to play Outlaw King. And so that click action to play gets transmitted to the machine that is serving, the web server serving that image, the metadata portion. Once the play button is played, this control is handed away from the web servers over to a content delivery network. And this is something that you already know. Amazon calls it CloudFront. There are probably hundreds of other content delivery networks available out there. You've probably seen that in an exercise that we did early on, like in a bucket and put a content delivery network on top. At least we discussed that. We did not actually do an exercise, if I don't remember right. But besides, the point is that this content delivery network basically takes the items from the bucket and shows it to you. And so you press the play button, the CDN will be responsible to play that video in the format of your chosen device to you through the CDN like that. And when you press OK, you're transitioning from whatever you see from here, and you are not seeing that one anymore, but instead you're going to see whatever the movie play experience is actually rendering on your device. So you may want to choose the device of your choice, which happens to be Xbox, for example. And so I am on the Xbox, I press the play button on the Outlaw King movie, and then that Xbox version of that movie gets delivered to me from the content delivery network onto my device, and I see this movie playing. And that's the idea behind what is going on under the hood. Now let's go see some experimentation. Let's go do some experimentation with what that movie is going to be. So if I say click on it, I hope it doesn't play. So I think it is playing. So let's go look at the URL. So I'm going to copy that URL and bring it to a notepad. And here you will see some of the characteristics of what I'm talking about. So I'm going to make this notepad a little bigger, and you can then understand what's going on here. So let's go see if we can roll this a little bit, soft wrap. Okay. So what you see now is the URL that I copied from the web browser window after I clicked on one of the OK movies, whatever that movie was called, OK, Outlaw King. Now let us dissect this URL to see what it actually is doing. So here you see Netflix.com, fine. Then there is a watch portion. Then there is an ID, ID number. Then there is a track ID. There is a movie ID. There's a track ID. Then TCTX ID. It's a long number, followed by this percent, which is a breaker. And there's another percent, which is another breaker. And so there are some markers here that go along with the track ID and the item number 11, line number 11, and line number 13. Those are the items. Sorry, let me adjust a little bit. So we have item line 6, line 8, and line 10 are the key indicators that are being passed along to the netflix.com/watch website right here. This destination is receiving this information and a bunch of strings passing along. Now this contains information probably about the movie itself and the identifier for the track sitting corresponding to this OK for Xbox. So there is a movie called OK or whatever that. What king was that? God knows. Some OK, some king. Outlaw. I should write it down. Outlaw King. That movie. So that movie number. So every movie has a unique number. Then there are track IDs corresponding to that. And there are some encrypted details that go along. That is hard to interpret because we have no idea what this is. But basically what this is actually hinting at is credentials of me as a logged in user. Am I allowed to play that movie? Can I hand off this URL to anybody and can they click on it and expect the movie to play? Absolutely not. Because you need to have a cookie authentication sitting on your browser window that allows you the authority to play that video. It basically means, excuse me, basically means that you need to log in. You may not have logged in, and so you have to log in through your account and then get to the movie to play it correctly. These credentials or these strings here in line number 10, 11, and 12 are basically encrypted. We have no idea what's going on under the hood. But what I can tell you is a insight into what may be happening. And so we'll now discuss that briefly. I'm going to clear this illustration and minimize this and go back to my white sheet of paper. And so here, what we are really looking at when the user plays the play button is that this particular movie for the Xbox target format comes along and it plays here. Now we can start playing and we can watch the movie, and the movie may be like, 180 minutes long, roughly estimated. And so we can, watch this movie up to say 37 minutes. And then on the Xbox, I get tired. So I pause. And then I want to, be a passenger in a car and drive somewhere. And while driving, I want to continue to watch that same movie. So this OK movie that I am watching, I open it, the same movie on the iPhone as I am a passenger in a car and in the back seat, and I want to watch that movie on the iPhone. So I open my iPhone and I look at the experience I'm expected to see. So I will search for this movie that I was interested in, and I will be prompted that, hey, you were watching this movie at this time. Do you want to watch the movie from 37 minutes onwards up through 180 minutes up to the end of the movie? Is that what you want to do? And you typically get the option like that. Now, the questions I have for you is, for a video file that is designed to be played for the Xbox, and there is a different file here designed to be played on the iPhone. And so the question is, this movie that was playing here was the Xbox format. And now you pause playing it at this time. And then you walk away on a completely different device and you're in a completely different location, completely different internet service provider, probably. You're on a phone as opposed to a cable modem or some home-based internet. And so it's a different scenario, but only thing that is common is your login. You have the same login profile that you have on the phone, and you say, I want to watch this movie again. And it prompts you, do you want to start from this point onwards? And in effect, what we have to now do is understand that Netflix, what it has to do is not play this format, but a different format. So thinking of this, you can actually visualize a scenario where a movie file, let's call it the OK movie for 1080p format, played on the Xbox .mp4 is currently playing that movie, and it played through 37 minutes of the video. And now you switch and you say, I'm on the iPhone now, I want to watch the same movie on a 1080 format, but on the iPhone. And it is not an MP4, but an M4B video. So it's some different format. And I want to watch, this file is also sitting right there, by the way, in the same bucket. And it is a different file though. So the questions I have for you is, how will you think about or envision that, when the experience of a user expecting that this movie should start playing from that point in time onwards, as opposed to, just starting from the beginning or starting any random time, which doesn't make sense. The best scenario is to let the user select from the time that they paused at and watch it from that point onward. That's the best user experience scenario. So how can Netflix pull this off? What do they need to keep track of under the hood, behind the scenes, when they are rendering that experience to the user? What do they need to keep track of? That's the question I have for you.
Maybe the timestamp of whatever they're watching.
Yes, exactly.
When they log out or close the screen.
Right. So the key thing is timestamp. So at least you understand what was the point in time which was being played, so you can then resume or suggest to resume from that point onwards. So this timestamp has to be captured by the Xbox machine and needs to be sent over to Netflix. See, the movie is coming from Netflix to the Xbox. Now, this information about the timestamp at which the user paused the movie, it needs to go to Netflix. And not only this timestamp, but there are a whole host of metrics that Netflix collects all the time, even when you're not doing anything. Just the fact that you started Xbox and you then kickstarted and launched the Netflix application on the Xbox, the collection of metrics starts. A bunch of things automatically start to get measured. But one of them is, how much bandwidth do you have between the Xbox and your nearest Comcast or whatever your ISP is? How much bandwidth do you have? What's the latency? What's the bandwidth? What is the jitter? Jitter is this is a standard English word. The meaning here is basically an indicator of variance, a statistical variance. That's what you will understand how fluctuating the flow of packets is from one point to the other point, and that measurements immediately start. Next, what happens is the user who started the Netflix app on the Xbox or any device, by the way, for that matter, this action will automatically start collecting metrics. And at that point, the user will be presented with choices of various movies. Say you want to watch this or that, or this or that, or search, or maybe something else, and some other things you will see as you saw in the Netflix website or the Netflix app on the Xbox. So these pictures or data about the movie or metadata will populate right there. And you then get to select one of the movies, like I was thinking of the OK movie here. And so that's the scenario that you now look at. And what Netflix app is also doing is keeping track of what I may be interested in clicking because they're looking at my mouse hover or my game controller hover and game controller or some other finger where my finger is touching. And so they will know already what I may be interested in. And apparently I was interested in the OK movie based on my mouse movements in the browser. So they already know what I may be interested in. And what they do on the back immediately, as soon as they detect that there is a likelihood of me selecting the OK movie, and I click the play button, at the very same time, even when I'm about to click, they already start downloading the movie. Not the whole movie, but bits and pieces. The bits meaning the chunks that I mentioned, streaming chunks. The initial few streaming chunks are already downloaded and cached. Now, at that moment, if I decide that I don't want this movie, I want another movie, the cache will be deleted and they'll move on to other movies. So I want to now watch the other movie. So now I'm about to play the other movie and I'm about to click this movie to play. And so as soon as they detect my mouse is kind of hovering over on the other movie, they will grab chunks automatically down and make it ready, basically prepare for the eventuality that I expect the movie to play as soon as I hit the play button. That's the eventuality that they're preparing themselves for. This is, the phrase is called aggressive prefetch. You're basically fetching down the chunks of the movie, the initial few seconds of chunks, aggressively prefetching for every movie that you think the user may be interested in watching. And thereby, just by the fact that you are getting aggressive and you're prefetching, pre-downloading bits and chunks as the user's behavior seems to indicate, that you are actually doing a user a favor. What you're doing essentially is, as soon as the user plays the play button on the other video, that you are able to show the other video actually playing along. And so the video plays. And that's the experience people expect. And so by modifying some of the behavior of the application and not waiting until the user plays the play button, but being a little aggressive in prefetching chunks that the user may expect to be available as soon as the user clicks the play button, is something that is a behavior that you will see in almost every single video player these days. Call it Amazon TV, Apple TV, or any of the streaming services. They have apps. They all have picked up the same idea, is to aggressively prefetch a little bit ahead of time so that the user is given the illusion of instant gratification, which is not exactly true, because it's not instantaneous, because they already started prefetching even before you click the play button. So that initial few seconds of no buffering, immediate play gives you the satisfaction. And now they already know that you are playing. So now they're going further prefetches and filling up the buffer a little bit ahead of the real-time play. So if the play is happening at this point, they are already aggressively prefetching future segments and keeping them in local cache, so that you watching that movie plays smooth. And that's what you expect. And that is one of the ideas that you will see, that you rarely have buffering. In most cases, people don't have buffering of a video getting blocked. But if you do, that is also detected. And that detection is basically going along right all the time, collection of metrics. The moment you start your Netflix app on any device, the first thing Netflix will check is how much bandwidth you have. And try a trick next time when you open Netflix, is that you disable your internet and disable the internet on the device, and then you play. Then you start Netflix app and you try to play something and see what happens. Netflix will immediately detect that you are not connected to the internet and tell you that you are not, which is a very, very possible scenario, that you are not connected, because you know that you disabled the internet to begin with. So Netflix is able to detect that you're not connected and tells you that, you know what, you're not connected. So try connect. Now, this other scenario is kind of hard to pull together, which is I would like you to get poor internet, which is very hard these days. It's difficult to ask somebody, hey, can you simulate bad internet? You need special tooling to make that happen. So I have that tooling. I can actually simulate poor internet for a device. And what you will see is the moment you have such a device with poor internet connecting or attempting to connect to the Netflix service, Netflix running here, the app running here will actually will detect that your signal is poor. And it is basically doing a bandwidth calculation and tell you that this is not enough bandwidth. It will report back to you saying you have poor internet connection. You should call your service provider. It will immediately tell you to do that, as opposed to waiting for you to get frustrated. And when you get frustrated, then you call Netflix. But they don't let you call Netflix because they are taking care of you, making sure that you're not frustrated by telling you upfront that you should call your ISP because your internet is poor, which is very likely the case. If you actually have poor internet, that you will blame the ISP and not blame Netflix, which is how they are managing the experience part of it a little carefully. They're taking precautions and making sure that they're measuring the bandwidth. And if they find that it is below a certain threshold that is not able to provide a good experience to the user, they are stopping the application right then and there and saying, you know what, call ISP. Thereby, they're clearly demarking the experience frustration root cause as to, it is not Netflix that is actually doing the problem to you, but your internet sucks. So call the ISP. That's why you see that, people think that not that I'm a big fan of Comcast or something, but there is this thing called Comcast. If there was a survey happened, I think a couple of years ago. People were surveyed about who are the worst customer service companies. Worst customer service. So people rank number 1, 2, 3. Number 1 was Comcast. The worst customer service. Number 2 was Internal Revenue Service. And this is basically means that you would rather get audited by the IRS than call 1-800-Comcast. That's how bad the experience is, by the way, with these companies. And they're also to get, they have blame to receive, and because they're bad, they suck. Yes, I'm using Comcast right now, and unfortunately, that's the only choice I have. But I'm saying that, what, they also need to get the blame because the customer service is actually bad. It's horrible. Having said, I hope the internet doesn't break on me today. But the point is that there have been cases in the past in which Netflix and Comcast will fight. And the fight is actually well published. You may have heard of this thing about, the recent news. There we go, more news. So let's go see what this is. So if you can see what's going on, the news is September 2018, YouTube Netflix videos found to be slowed by wireless carriers. This time it is not Comcast, but the same concept applies. Now the same concept here is that, there is a video service and there are these internet service providers, and they are deliberately doing something bad. And this is a research finding from somebody, some Wiki app shows something happening. So that's a research. But similar to that, prior historical cases, there was Comcast was doing this thing called traffic shaping and basically throttling Netflix for a very simple reason. It was a business reason. They were deliberately doing that and openly doing that because they wanted to extort money. Yeah, I'm not kidding. That's what happened. The idea was that you will, Netflix basically depends on Comcast. to provide a pipe or the ISP pipe, to the customer so that other companies are less interesting. So this is the competition, less interesting, more interesting. And when you have a Hollywood video you want to watch, a movie made by Hollywood, the customer wants to watch, the fact that you have an internet service pipe, fat pipe, big pipe, bandwidth, high bandwidth pipe, it's available to you, then it's Netflix becomes interesting. That's the idea here. So they kind of depend on these guys for the customers' useful experience of watching the movie that they want to watch. And so what Netflix is doing, what Comcast was doing, is deliberately shaping traffic. Meaning, excuse me, meaning the pipe that they had, as it, excuse me. So the pipe that they had that goes to the customer carrying Netflix traffic, they narrow it down. Everything else wide. If it carries the Netflix traffic, you narrow it down deliberately. You're deliberately narrowing traffic when it originates from this source. When the source is netflix.com or any of their services, that you shrink the pipe and thereby distort the customer's experience. They were doing it deliberately, these guys. And so they fought a lawsuit and eventually settled, through which I think Netflix paid Comcast a lot of money to basically broaden the pipe again. Basically, this is bad extortion. But apparently it was legal. So yeah, I have no opinion on legality, but that was the case. So they basically extorted money from these guys. And in return, they let them have a wide pipe so that the customers are happy. And on the other hand, what Comcast did is they bought Hulu. This Hulu thing that you already know is owned by Comcast. So now, not only that they are, making the pipe narrow, trying to extort money from Netflix on one hand, but on the other, they're buying Hulu and playing the heat or the game in a different direction. So this direction. They're saying, you know what, you customer, you just come to Hulu. And that's a competition option available. You will soon see eventually, and I'm making a prediction here because based on my understanding, is that Disney, who is currently providing movies to Netflix, you will find that Disney will stop providing their movies to Netflix and say, you know what, Disney service. That is being developed, I understand. And that will be another choice available to customers. So yeah, you want to watch Disney movies? The only choice you have is not Netflix. So you have to go here. That's the game that Disney is trying to play. And people are Disney fans, and so they will just go there directly. That may happen. You can actually see some of the trends in that direction already. Like, for example, Disney, Netflix. It's a deal now? Okay, let's see what the deal is. Okay, it's the end of the deal. Okay. So Disney to end the Netflix deal and launch its own streaming service. That's a news right there. Okay. So yeah, it is happening, it seems. And so that is basically how the games play out. These are the concept that we are talking right now about game is actually an economics term. The economics portion of this is called game theory. And so read more about it right here. This is a branch of economics, and the book that I mentioned, Co-Opetition, is actually a game theory book. This book that I mentioned with this picture in our discussions, that Brandenburg or Nailbuff book is a game theory book. And this is the subtopic in that same game. Basically, these are economics and business books. And that is the book mentioned right there. This book is actually a good one, Co-Opetition. So having discussed these ideas, I will now further identify some of the items in the aspect of what Netflix is doing in this illustration that we just discussed from a different perspective of how this illustration of media sharing can be generalized. So I will now erase some of the ink here I have and make it clean so that we can talk about the same again in a different fashion. And you will now see that this chart can be generally applied to other cases of use, other entities that are in the business of, okay, what is that thing? Okay, so other entities that are in the business of media sharing. Can you give me like 2 or 3 examples of companies that are in the business of media sharing that are not Netflix? Like 2, 3 examples?
I can't, it's on the tip of my tongue. I can't think of it.
Okay, I'll give you Hulu, right? That's one. Disney, I just mentioned. Netflix is one. Amazon TV.
Yeah.
Yeah.
Amazon TV, Apple iTunes. They also show movies, right? Not really exactly the same business model, but it's the same idea that you can go to iTunes and watch movies like this. And so you've seen it. You can go to music. Oh, it requires sign in. Fine. Okay, you have to sign in now. And so cancel. I'm not interested. I'm not interested in movie playing, but you already understand what I'm talking about. So it plays movie. It is not a rental. Sorry, it's not a streaming subscription service. It is a rental. Apple has purchase options. For $20, you can buy a movie, or you can $50 buy a standard definition movie, HD movie, or something like that. Some other pricing you will see, and these are the purchase items. There are also rental items, which is like you can rent a movie, HD movie for $6.99, or you can rent a standard definition movie for $4.99. And the rental operation will allow you to watch a movie for 48 hours after you first start playing, and then the rental goes away. That's the rental model. They don't have the model like Netflix does. It's subscription model. That's not there with Apple, but they might come up with, who knows what they come up with. So this subscription model is you pay $9.99 every month and watch all the movies you want that are available in the long tail. Not the ones directly, like you cannot watch Bohemian Rhapsody right now. It's not there. There's no DVD and no streaming available quite yet. So DVD, when it comes, typically you will see the buy options become available in Apple at probably the same time. On the day DVD becomes available in a store, this buy option becomes available in Apple and in Amazon TV, Google TV, bunch of other places. So those are the commonly known media sharing sites or services. One thing that you can actually see in the same picture that you will understand, and you will probably appreciate the moment I bring it up, is the thing that is not actually an entity like these, but a slightly different video sharing service. And that is called YouTube. In here, you have a double role, 2 roles. You are the person who watches videos, like cat videos and funny videos and all that. Whatever you do at YouTube, right? That's what you watch, cat videos. And here you have the other role. In the other role, you upload videos. You upload the dog video. You have a dog, the dog does funny things, and then you upload that video. And so that is the other role of you. the two different roles. And I hope you will agree that that's a valid use case of YouTube, right? So in that scenario, you have these two roles that I just mentioned, but imagine now you are taking on this role. And so in that role, I will now change my ink color to some other color, like say blue, for example. So let's call it the blue color. And in that blue color, you're basically taking the dog video you have, and people like you who are uploading it like that, just like that, their dogs, your dogs, everybody's dogs goes up into the elastic load balancer, which runs in auto scaling scenario, and you go assigned to this, and that other person gets assigned to this, and then there are hundreds of other users, and maybe thousands, and maybe millions, who knows how many people upload. But that's people like you and me uploading dog videos. Or people like me who upload Cloud Genius videos, right? I create tons of videos every single time I run the session. There's a 3-hour-long video. I will actually do the upload. So I am right there going to be doing that in like after the session at 7 o'clock. It finishes, like right now it is what, 5? And so in the next 2 hours, I will be doing such a thing, right? This thing. Except I will not be sending it to YouTube. Maybe I do, sometimes I don't. But most of the time I send it to Vimeo, which is another service like that. Vimeo. That's another video service. You may have heard of it. But that's my preferred service, where I will send my uploaded session video, 3-hour session, and I upload it to Vimeo. And then that link becomes available in the Cloud Genius website that you've seen already. So that's the role that I'm taking in this blue segment. I have upload servers, and yes, there is some processing involved, and there are some these things also happen. Then I get the output available in a bucket that basically gives me a link. Vimeo gives me a link like that. That is what I embed into my web servers. So that this is me uploading a Vimeo video or a YouTube video, same ideas. And this is you watching. And you want to watch, this time you don't go to Vimeo because there's nothing to see there. But what I do is I actually take a link from Vimeo and embed into these web servers. So when you go, you reach here. And there you will find a link, and you click on that link. It takes you straight to the CDN. And through the CDN, you will go to Vimeo's buckets, and then the Vimeo video will play. You can see these things happen, and I'll show you live right now. So here we go, an example of clear understanding of what just I mentioned. Is the thing that I actually do almost every single time. Most of it is automated, but I'll do it manually right now. I'll just show you what's going on. So here is your architecture video series somewhere here. So you can see that there is this web browser pointing at a website called whatever, be a Cloud Genius, whatever that thing is. And it is going straight to this destination where I have my upload web servers. And that is where you go typically, to that website. And so in that location, you will see that I will now show you the links. Is that you are on this website on a particular page where you see a link. And that link will show like this. So let's go see the page. This is not the link, but I will now open the link. So this is the video number 1, 2, 3, 4 videos. November 7 was the last one. Today is November 9th. So now I will edit that page manually. And you can see this page being edited, and I will now extract the link from there. And here are the links. So here is the November 7 link. And just like that, at the end of the session today, there will be a November 9 link. And the link is right there. Let's go copy that link. And I will update this page. And you will see that that's what happens through automation. And you will see that at the very end, there is a November 7 video, which is identical to November 9 video. And that's a mistake, obviously, because November 9 video is not ready yet. But I just used the link for November 7, and I pasted the same link here on November 9. Now that is a mistake, obviously, but I hope you understand what I'm doing. What I'm doing is I'm pointing out to you that the link that I pasted was this. And in there, I have a source coming from Vimeo, width, height, frame border, WebKit allow full screen, Mozilla allow full screen, and an iframe. So let's go edit this a little bit, clean it up. The source is line number 8. And then there are certain characteristics. The other characteristics are not that important, like width and height and frame border. All of these are like useless. So I'm going to erase them. This is the idea, this link. That's where the link is coming from Vimeo. So I will go to that, copy that link. And I will now open that link on a browser window like this and say, hey, click, boom. And what do you see? And tell me, why do you see this? On the other hand, if I go to this page and I play the video, it plays just fine. We are recording this. See that? The same video, when I click here, it plays. Line number 8 plays just fine. Line number 6. What is going on? Do you know?
I don't know the details, but I'm assuming there's some sort of parameter or property where people can't copy and paste, because then everyone would have content to the course material.
Yes, exactly right. That's what I wanted to hear. So thank you. Your understanding is super clear. So that's exactly what I'm doing, is I'm preventing the direct exposure to links and allowing them only when watched through this website.
Mm-hmm.
Right? And so that's the kind of structure you will see in every video sharing site where the content is uploaded. So I actually, like the last session here, like 2 days ago, whatever that was, cloud architecture, this November 7 video right there is playable. And hey guys, we are recording. And I am currently logged into Vimeo. That's why this plays. On the other browser, I was not logged in, so it doesn't play on this browser. But this browser, I am logged into Vimeo, and I can, upload more videos if I like, and I can just drag and drop or do other methods to send the video up. Like I can choose a file and send the video up, or I can just put it in Dropbox, Google Drive. There are other techniques to upload, and other apps are available. So you can automate the upload also. But the point is that this action of upload can be done either by a person or a robot, which is either me or my robot here, taking the video, sending it up to a Vimeo server, and then it becomes available in the bucket in its original form, and it also gets processed so that it delivers correctly on other forms based on the processing necessary. And the processing result is also available that generates a link. I'm taking that link and putting it in my web server so that when you come along, you are able to watch that video through the link I gave you. But if you try to go to that video directly, access denied. Access is allowed only when you go through the website through the link that I authenticate, like line number 8, not line number 6. So that's the idea of how do you actually make sure that your users who are genuine users are able to watch and not anybody else. That's one of the ways to ensure control. There are many ways to actually enable this kind of a secure setting, but the security aspect is not what we are actually discussing right now. But the more important idea is to understand that there are these two roles of upload and view. Both are being addressed in these two portions of the same architectural diagram, which are this segment is the upload pipeline, and this segment is the render pipeline, the viewing pipeline. So the views, initial views happen here, and then the video flow happens through the content delivery network like that. That's where the videos flow. This is where the information about the video will flow, and video go up this direction. Having seen this and understood this concept, I would like you to take a moment and think through other questions that may not be answered, or any ideas that you want to bring up for discussion. I welcome that. Thinking about what this thing is and how does it apply. And by the way, there are like 16 more such charts, and I would like to discuss them. If you are interested, or if you're not, you just tell me that you're not interested. That's fine. But I have them, and I am trying to gauge your level of interest in discussing cases like these in these pictures. We have like 16 of them in that link that I gave you in chat window. They're nicely done illustrations, and I want to actually cover that. So I will do that, but I want to spread it out and maybe mix and match with a little bit of exercises in between before we jump into academic discussion on these things. They can become boring, by the way. The idea, the question I have is, was this Netflix discussion that we just did, was it boring to you? Was it useful to you? Was it not hands-on enough?
I found it to be very interesting.
Was it boring at any time? Did you fall asleep because I'm not doing anything like actively engaging a machine or a service?
No, not at all.
Okay, good to know. All I want to make sure is that you don't fall asleep, because if you do, then it is my problem. So I don't want you, to put you to sleep by what I call singing a lullaby. Okay. Any questions on this idea or this sheet specifically?
No, not specifically on that. I'd be interested to see if a couple more, maybe with different businesses that would kind of follow along different diagrams.
Yes, indeed. There are various, and we'll probably discuss quite a bit of other examples also as we go along, but maybe not in that level of detail like we did with Netflix, with every single item from its history all the way. I'll definitely give you a high level overview of all these guys, but right now what I want to do is some hands-on work. So what I would like to now talk about is this idea of auto scaling, as to how does it actually work. Like we have seen this auto scaling mentioned 3 times, right? In the upload pipe, in the processing pipe, and in the user delivery pipe, or the video delivery pipe. The 3 segments where we have at least this reference to auto scaling, and that is something that is important to understand and make use of. So that's what I will actually go do a hands-on exercise with, which means I will go to Amazon or some other service and play along. What I want to talk about in that context is that there are these ideas that I want to make sure that I clarify, is that you will put machines, virtual machines or containers or whatever you have, on a subnet. And you will put 1, you will put 2, you will put more, and like that. And you can keep adding. Or you can keep subtracting. And this is called grow. This is called shrink. Now this grow and shrink, you can do it manually. But doing it manually is boring. So you want to do it automatically. But if you want to do it automatically, then you need to understand policy as to when will you grow. Automatically doing, you need to understand and write down very clear policy about growth. What's your grow policy and what's your shrink policy? Shrink policy. Which means you need to understand when will you trigger a growth and when will you trigger a death. A death meaning you shoot the cow or shoot one of the machines. And grow meaning you add one more. So there has to be a trigger here also. And the trigger has to be mechanically calculatable in form of automation. So you need to really understand what will you measure and what will trigger the growth. What will you trigger a decay or a death. And that's the underlying idea behind auto scaling is that it is not just scaling manually, but happens automatically. That's the reason it is called auto scaling, because it just happens by itself. You need to also define, when you grow, what exactly do you want to grow? Meaning you have to specify this machine, its operating system, its size, its subnet, its every little detail about what does it run, how do you make sure that it has the data, the application, whatever it needs to be having, you need to make sure that it has every exact that thing. So you have to basically write these things down also. When I want to grow and create a new machine, what do I use? A template. So I can just blindly copy that template and create when I have a trigger for growth. And shrinking is very simple. Just pull the gun and shoot. It's easy. Shooting is easy. Growing, you need to know what do you want to grow. So you have to have a template of some sorts. And so that's what we will do live hands-on now. We'll actually create a auto scaling group in the Amazon cloud, and we will see what we will be using in form of triggers to automatically grow and automatically shrink. Now I'm going to make a hypothesis here right now in order for us to succeed with the demo. It's going to be live, and so I hope we succeed. We'll go to this site. In there, we'll set up an auto scaling group. And it grows or shrinks. And I'm going to put a hypothesis, is that I will assume that the CPU percent consumption grows when I have lots of users. That may not be true all the time, but I'm just making that assumption. When I have lots and lots of users coming onto the site, then my CPU consumption will grow. That's it's probably a stretch of imagination. Little bit of stretch here. It may not grow. You will just have users. It may slow down. So I'm going to use this as a proxy metric. Because what I really want to measure is not how many users I have, but how happy they are. That is very hard to measure, happiness. It's very vague. The best way to measure is to ask the customer, hey, are you happy? Like I just did like 5 minutes ago, I asked you, did the Netflix exercise bore you? I just asked you upfront and you told me it was not boring. Probably you find it, whatever, useful maybe. Yeah, so it's easy for me to do that, is to ask you, hey, did you like it or not? Simple question. And that's easy to do for me, but it's not always the case for everybody. Netflix cannot go ask everybody, hey, are you happy watching that God knows what movie you watched? Okay. They cannot do that. There is no way they can actually afford to by going out to everybody and asking, are you happy? So they have to have a proxy metric to measure user happiness. If the users are not happy, maybe you want to add more machines and make them happy. That's the stretch. That's what I'm really calling it, as a stretch. But it's not actually necessarily always a stretch, because there has to be some way of measuring, some kind of a metric to eventually translate to what you really want to measure. And it may not be CPU consumption, but I am going to use that as a proxy in our example right now. I just want you to understand that I am going to use this as a method of trigger. A trigger that will trigger this policy, and a trigger that will trigger this policy, shrink and grow policy. That's what I will be doing right now. And I'll go and do that. So here on the browser, I will go to Amazon and log in. And there I will go to a method which will create Okay, this needs explanation. So, okay, hold on. So I think I need to explain this. I haven't explained this. So, okay, let me take a few minutes to explain this to you. So what I'm doing is I want to demonstrate this idea of growing and shrinking automatically based on some proxy metric that I'm going to use, and this is the metric that I want to actually put in place. And so I want to have an auto scaling group, and so I can create an auto scaling group manually myself, like totally by going step by step and doing it. It takes a lot of time to do manually. So what I want to do is to create an auto scaling group. I will use automation. What I will do is I'll play the automation technique that will generate an auto scaling group that I want. So I need to specify the details of what auto scaling group I want in the cloud. I need to specify that. And then once I specify, I can ask Amazon, say, hey, you go create this design in your cloud based on this specification. So this auto scaling group gets created. And this specification is written down in form of some files. You need to have some files, put them in a bucket, and that specification, you have to ask Amazon, hey, look at the bucket, see what I'm saying, go do that. And that is what it will do. So it gets, auto scaling group will get created. By the way, this concept of you specifying something is a general purpose tool available in almost every cloud has it now. So let's go understand that concept a little bit before we use it. So let me recap what I just said here again to simplify our understanding. Our understanding is that we will write down our specification in a file and say, hey, this is my design of my cloud, which in this example will contain an auto scaling group. It can contain anything you have in the cloud. It doesn't matter what you have in mind. It is your design. You specify in some files. That's your intention or your desired state. And you write that state down in some files. So let's call this a template, or you can call it whatever you like. I'll choose the exact name that every cloud will use. And so I will tell you that name at a later time. But right now, these are the various names I will be calling. It is basically a file, or maybe more than one file, mostly one file. So let's call it a file. So there's a file which contains your design, and you say, hey, Amazon, apply this design to the cloud, and then Amazon will apply that design. In my design, I have auto scaling group. So I get my auto scaling group created because I asked Amazon to apply the design. That's one scenario. In the second scenario, what I do is I do the reverse, meaning I go to the cloud and I create something here, bunch of things, any number of things that you like. And I do the opposite. I'll say, hey, Amazon, look at my cloud and give me a template that captures my design. So this is like save your design. Or you can call it download my cloud. That's not how people call it, by the way, but I'm just saying download your cloud. So it becomes in a file available to you. And then you can use that file and apply. Totally possible. And that becomes your new cloud. So in practice, not just in theory, what you can do is go to Amazon and say, create my VPC, create this subnet, create that subnet, create a bunch of machines here and machines there and like that. And this is my entire complex design. And I've done it like 3 times. Now I'm getting bored. I don't want to do it again. But I have my team, and the team has like 37 members. And I would like each one of them to be able to exactly reproduce the design that I created on this cloud in my account. And I want my 37 team members to be able to exactly reproduce whatever I did. I took like 3 attempts to really fine tune whatever I had in my VPC, and bunch of things I've created: setups, configuration, security group, firewall, NAT, your subnets, your routing rules. Oh my God, the whole thing. You know that thing. I did it like 3 times, and I fine tuned, and it's working beautifully. So I want to now exactly reproduce the same thing for 37 members in my team. Now I had to go sit with everybody and tell them how to do it. Each one of them will do it 3 times. That's boring. And so I would rather just do it for them in an automated fashion. So what I'm going to do is ask Amazon, hey, I built this nice, beautiful design. Why don't we just dump what was the word I used? A file, a template, my desired state, my design, my specification, whatever you call, just dump it. So I get a file. Awesome. That's what I wanted, because I will take that file and now give it to my members in the team, 37 of them. Each one of them can take that same file and go to their own Amazon accounts and say, hey, take this file and apply. And there are 37 clouds now running the exact same design I had here. Exactly the same. Here and here and here. And all it takes is basically say apply. Apply this, dump this file. Just apply. That's the tool. That's what Amazon and most other clouds have created by now. So we have it. So essentially, it is a transition from a cloud to a file, or a file to a cloud design. This exact design, same design. You can go this way, or you can go, this way. Both ways are possible. There is a name for these things in Amazon Cloud. So this thing is called, what's the name? Hold on. It's called CloudFormation. So CloudFormation. Other clouds will call it something else. They operate basically the same way. You have a file, you apply it to the cloud, and you apply to get the cloud, dump it in a file. Take the file, dump it to the cloud. It becomes actually a fully functional cloud. And you will see this now. There's one more thing to understand, and that is this scenario of taking a file and applying it to the cloud to create this exact cloud setup is easy, because the file is ready. You just say, hey, Amazon, take my file, go do it. So you just go to CloudFormation, give them the file, and they will create the cloud. The entire design will be started up and running, including all the machines and every single VPC, whatever you did, the whole thing, it becomes ready. So this is the easy part. The other part is not so easy, because you need to run some code that looks at your cloud from the outside. It needs to be out of your cloud somewhere else, that will then look at your cloud and find out what you got and dump it in a file. So this dump actually is coming from this something running outside. See, this part was easy. You take a file and say, okay, run it. So it runs. Here, it was already running to begin with. So what you're now doing is extracting the information about the cloud and trying to save it in a file in form of a dump coming from some code. And that extraction is to run in a process separate from the cloud itself, so that it will take a look at what do you have, identify every single thing, write it down in a file, and there you go. So that is the complexity here. And this needs to run in the Amazon cloud in a different segment, not in your setup, outside your setup, because that is actually not a part of your design. It's a separate tool running, looking at your cloud setup to find out what you have, and then it is dumping a file. You can use this file and create the same exact cloud again, totally easy. All you need to do is just say, hey, CloudFormation, take my file, and boom, it creates. The other one, you have to go pay attention to this scenario where you have to have another machine set up to look at your existing configuration and then dump a file. You need to have a way to start this outside code, something. You need to have that created, for which there is a file Amazon provides. This is called AWS provided file. And you have to go look for it. And that file will generate only this special thing that will look at your cloud and dump a file. Maybe that was not super clear. So I'll do it like one more time to clarify this. So let's go try it now. You have a file, easy to get to a cloud, easy. You have a cloud, not so easy to get to a file. So what do? Is you a special file to create a special machine, runs outside your cloud, the separate special machine AWS file, and it's a separate AWS. You have to pay for it, but separate from your cloud. And this looks at your cloud and then dumps the file. So that this is something that you need to know where it is to create this separate box that will then look at your cloud and dump it. That's the convolution, or rather, it is convoluted somewhat. But that's how it is implemented. So just understand that that's what we are going to deal with. So we have to first use this ready-made file to create this separate tool. The tool looks at your cloud and dumps the file. That's the convoluted idea. That's pretty much it. I think this picture will probably recap the whole idea that we are going to discuss now with real examples. So here it comes. And if you just look at this screen, it might confuse the heck out of everybody. I don't know why they do it this way, but they have these names that I don't understand. But you don't have to worry about these names. They call it stack and stack set and template and God knows what. But just erase all these words from your mind. Focus on this idea, and this is what you need to begin with to create this thing. This thing is called, let's call it, the name Amazon uses is called CloudFormer. That's the name of this tool. So we have to create a CloudFormer tool that will look at our cloud and create this file. That's the scenario that we are going to now look at here. Create a template from your existing resources. See what the subject is, the topic is. It is this topic. Oh, sorry. No, not that topic. It is this topic. Your existing resources. See, you have some existing resources in the cloud. You want to create a template. That's what you want to accomplish, right? So it says, create a template from your existing resources. Okay, very easy. You just click the CloudFormer, which is what I'm going to create, this unit, the new machine getting created, which will then look at my existing resources and dump a template file. That's what I want to actually create. And by the way, this doesn't dump. The dump happens from here. The CloudFormer dumps. It looks at this and dumps the file in a bucket. To start this, we need a file, and that's what this file is. This specific file. If you go look at that file, it is basically a template, this template. Let's go open that file in here. It looks like this. And it is, come on, why is it so complex? I'll simplify it with the soft wrap and see where it is sitting. It's sitting in an Amazon bucket. Bucket name is CloudFormation Templates US West 2. And the file name is cloudformer.template. That's the file name, cloudformer.template. This is the bucket name. And that's the location of the bucket, 1, 3, and 5. So if you go to that bucket, you will find that the bucket contains this template. So now we'll go look at the template itself. And it's a very, very long file. You can see it, it's right here. It is going to open. And it is actually a JSON template. So you can see the JSON template. It is a JSON file. And let's go see the JSON. Here it is in a JSON format. So it's easier for us to read. And it has some information about the date and username, password, setting, create a new VPC action, and goes on and on and on. And it is fairly complex, actually fairly complex. But it needs to be complex because that's what is used to create a tool in a separate location. The tool is called CloudFormer. This runs in a separate machine, EC2 machine, I think somewhere. It creates a new machine and then becomes ready. That CloudFormer tool, we will run it at some point when we do another exercise. That is also coming up probably in the next time. So we'll run this CloudFormer tool, we'll apply it to our own design and then have it dump a file. For it to dump the file, we need to have existing resources. So we need to create them so that it can then create a file like that. We haven't done any exercise quite recently yet. We did it in the past, and that cloud that we created using VPC and the whole exercise that we did early on, that is probably stale now. So we'll do the whole thing again, and then, by the way, a whole lot faster, like with automation. We recreate the entire set of exercises just like that here, and then use the CloudFormer tool on top to create a file like that. So this was the Amazon specific tool that we just discussed. What I want to actually do is use a file to create an auto-scaling group right now. That's what I really want to do. And I will then exercise the auto-scaling group and show you how it scales automatically, grows and shrinks automatically for real. And that's, I think that I hope I will succeed in that. So that's the game that we will eventually play, but I'm building our ideas towards it so that you really understand what's going on and it's not just magic. It is not magic. It is actually real. And so that's what we want to do. But I want to help you with another understanding of this same idea as to how other clouds do it. Other clouds operate kind of sort of the same way, and they have different names for it. Like they don't call it CloudFormer. They don't have a template that is what it looks like in Amazon. They have their own names. Let's go find out what their names are. And so we will do a quick, I don't remember any names, so I will just go do a search. And so I will say something like this: CloudFormation, Azure Cloud. What do they call? So it is called, click, that's the name, Azure Resource Manager. That's the name in Azure Cloud. Fine, we'll go and see it, check it out. Basically, it operates the same way. There are different formats, different templates. Concept is the same. So you can see this, you can read this yourself, comparing AWS CloudFormation to Azure Resource Manager. The whole paper core stack company, gives you the detail. You can read it on your own. I'm not going through walk through every single company's manufacturer specific detail about how this thing works. But what I will do is actually talk about an open source equivalent of the whole thing. You can apply that idea to any cloud. I will briefly discuss that and give you examples to play with yourself also. And that's the plan that we will do. Now, in another quick search, cloud formation, Google Cloud. Let's see what they have. What do they call it? And so it is called Google Deployment Manager. This is the name. And they also have similar ideas, that you have a template and you focus on your application. You basically tell us what template you want to apply to the cloud, and then you go with it. That's the tool is called Deployment Manager. The other guys called it what? Other guys called it Resource Manager, and Amazon calls it Cloud Formation. But these are all what I call vendor-specific tools. And so I don't like them because they are specific to only that cloud. I don't care about any one cloud. I care about all the clouds. So what do? I use open source. And there is a beautiful tool to get the same thing done in open source. That the tool is called Terraform. And this is the tool. This is open. And here is the documentation. This is the GitHub page. And we will use it in an exercise coming up next time. What this thing does does exactly what the other tools do, like the Cloud Formation tool and the Cloud Deployer tool, Google Deployer tool, and God knows how many clouds and how many names they have. But the problem with them is that they are custom and apply only to that cloud. And I don't like that idea, because I want to have my design run in any cloud of my choice, not their choice. I don't want to get locked up. Locking is an idea that I want you to understand. I think you already understand it intuitively, and that the idea is that is called vendor lock-in. You don't want to be, getting, let's say this in a crude fashion. You don't want to get married to the cloud company. That's the best way to describe this vendor lock-in. You want to avoid it. You want to retain the flexibility to switch between providers, A, B, and C. And maybe, if you don't like them, you just go here. Or if you don't like them, maybe you go here. Or maybe you use all of them. It doesn't even matter. And that's what I actually do, is I mix and match variety of clouds, whatever I like, from whichever cloud I like, and I just pick and choose my services that I really like for my usage, for my customers. Because that's what matters. If you if you spend all of your energy in one direction and you stick with that one cloud, then all of your team members are trained to use that cloud and they have no idea how to deal with the other clouds. And when you want to actually make a move, oops, that's a problem. So you want to avoid those things. Avoid lock-in if you can. It's not always possible, but it is possible to consciously think like that, so that you can actually use multiple clouds the way you want, the way your customers want, as opposed to just doing everything here. It may be a good idea, by the way, maybe a great idea to just stick with one cloud. Totally great idea. It may be, provided they're giving you money to use the cloud. If they more than compensate you for any potential problems, I would love such a lock-in if somebody is giving me money, and I enjoy that. And there's nothing technically wrong with using one cloud, as long as you understand the economic implications of switching. And that's the underlying idea of switching cost, which is something that you need to be fully aware of. If you get stuck with one cloud, then the cost to switch to another cloud becomes expensive. So as long as these guys are paying you more than what it takes to switch, I am happy. I will stick to one cloud. But unfortunately, there is no such cloud that pays you money to use them. You have to pay them money. So that's the reason why I suggest that, unless you are big company like Boeing, in which case Microsoft will give you like ton of free resources. I mean, they love that you're using Azure Cloud. So they give you Azure Cloud for free and maybe give you extra money and give you discounts and God knows what they do. But that's the reason why, many people in Boeing want to use Microsoft Cloud, probably because of non-linearity. I don't know exactly what's going on, but something that makes it interesting for you to use. So it's fine. You can use. There's nothing wrong with it. Just understand that, there's a switching cost built in. So when you want to switch, you want it to be painless, or rather, not so expensive. So with that idea in hand, what I will now do is discuss this tool, what this thing does. Let's understand. First thing I want you to focus on in the documentation is that it works with almost every cloud of you can think of. You see the list here. Here are the major cloud providers. Who are the major ones? Let's go look. It works with Alibaba Cloud, Amazon Cloud, Azure Cloud, Azure Stack, Google Cloud, Google Cloud Infrastructure, Oracle Cloud, Oracle Cloud Platform, Oracle Public Cloud, VMware, blah, blah, blah. These are the major ones. Now let's go see the other clouds, the not so major clouds. The not so major clouds are, okay, it's a long list. And it goes on. The infrastructure software it works with Chef, Docker, Helm, Kubernetes, this and that, and goes on. RabbitMQ, Rancher, VCS, monitoring deployment, databases, goes on and on. It's a long list of providers. You can see the whole list here. That's the reason I like it. I can use it with anywhere I want. In fact, let's see one of the exercises. So we have an exercise using this exact same idea somewhere here in the architecture segment. I think it is called, search keyword is NTIER. I think that's the word. Let me just quickly check. Yeah, there it is. So this is the exercise. Blueprint for an N-tier architecture. And the exercise is written down right there. And there is a video walkthrough. It's a 3-hour-long video. And that is something of use to watch. If you are, if you're doing that exercise, you should watch that video. It's a very long video to watch because it's a long exercise. But we'll run it live. When I'm doing it live, it may not take that long because I have already built up some of the thought in helping you understand what that idea is. And this idea, by the way, is going to create a VPC with these subnets and these machines and these security groups and route tables and everything else that you see in the picture. That's the underlying idea behind that exercise. It will create it. And the actual action of running this source code, this code is actually very simple. If you go to the code itself, you just go to the Terraform folder and run Terraform apply, and you're done with the exercise. Actually, literally that simple. So if you go, how do you run it? You run like, you clone the folder, you go to the folder inside, and then you go create the stack. So Terraform apply. That's all it really takes to apply the entire design onto the cloud, and it will bring up a stack like this, like you see in the picture here. Oops, go back. Like you see in the picture here, this picture. It has, in the picture, as you will notice, it has everything that you did in the first exercise, the early on exercise. You have a load balancer, you have a gateway, you have a security group, you have the public subnet here, the private subnet here. There are two machines, machine 1, machine 2. They are participating in your load balancer. There is a NAT device. The NAT device has the instance NAT. It has a public subnet, a public route table association. There is a private subnet, private route table association. There is a key pair that you will specify so that you can connect, and then you can have this user visit the load balancer and it will balance the load among two machines, and you will see that happen. And then there are additional exercises. So all of this design is constructed in one command, and that is Terraform apply. That is the same command that you saw me discuss pretty much here. And I said, take a file and say apply. So that creates the entire cloud. That's what we want to do today. We will do that, but using the Amazon tooling, so, not using the Terraform tooling, because I don't want to create, do not want to create this design right now. I want to create an auto scaling group. So it's a different template, not that exercise. So I will now go and find this template that I will apply using CloudFormation, not Terraform. Using CloudFormation, I'll apply to the Amazon cloud and I'll get an auto scaling group, and then we'll exercise it a little bit. So now we'll go and find it. So we'll say CloudFormation template, and there should be some examples here. And here we'll go to a region of our choice. So for example, my choice is Oregon region. So in there, I have some sample examples. And where is that auto scaling group example? Well, I'll search again. I did not find it. So I'll say auto scaling group, AWS, template, CloudFormation. Let's see what comes up. I think that's the one. Is it? No. I think this is it. This should be it. Let me just quickly read it so that I can get the right place. So is this it? This template creates a sample website using auto scaling, elastic load balancing, configured to use multiple availability zones. Template contains CloudWatch. Threshold is exceeded. And you can get the latest version of this sample template at that place. And let's go understand the triggers so that I can actually exercise them. Yeah, I think this is the right one. So I'll paste a link for you. And the link is coming. You can do this exercise live with me, but getting it to exercise will require a lot of tricks. They will involve you having to bump the CPU consumption a little bit higher than the trigger expectations, which is what I will be showing you live. So you may want to watch it, not necessarily do it with me, but you can. So here is the beginning point of the exercise in that location. So I have to get a latest version of the sample template available in this location, and I will go there. And it opens up this view that I don't want to see, so I'll go back. Instead, what I want to do is grab that template in my copy buffer. So copy link, that's what I want to do. So it's copy link location, that one. So copy that link location, and I want to use that link in my Amazon cloud. And here I want to go to AWS, and there specifically I want to go to CloudFormation, which is a management tool available. So management tools, CloudFormation, and there I want to create not a template because I already have it, but I want to create a new stack. A stack in Amazon's language means a bunch of resources that I want to use eventually, and I will create that through a template that I will provide like this, or alternatively, upload it to S3 like this, if I have a template locally, or select an existing sample. And in the existing sample scenario, I will make sure that I have the Oregon region selected, and then select an existing sample template. So I will now go look for it in this listing. If it is there already, single instance LAMP stack, Ruby stack, WordPress blog, LAMP stack, Ruby stack, WordPress blog, Cloud Former tools, more sample templates. There are more sample templates. And it doesn't, oh, there is ... more. Where is the, more sample template doesn't show me a sample template. But you know what, we have it here. And so, no, not there, not there. Let me close out there. This link that I gave you in chat, that link has the link that I'm interested in. So I'm copying link location. You will notice that this template creates an auto-scaling multi-AZ group in US East 1. So I need to go to US East 1, which means I need to go here and change my location to US East 1, which is Virginia. And then I use an existing template that I have in my hand. I paste that link right there, as opposed to selecting a sample, which is totally doable, provided they have a link here, but they don't have a link for the one I have in mind. And therefore, not going to be selecting a sample from that box, but instead specify it in this box, in this link I obtained from the documentation in the link I gave you earlier in chat, which is in the chat window. You see this link here, which is a walkthrough of a scalable load balancing web server. And that walkthrough has this latest version of the template. That's the link I'm using, but I'm using it in creating a new stack that I specify an Amazon S3 URL, template URL in that location. So this is the Cloud Template US East 1 location containing auto-scaling multi-AZ with notification template. And using this template, I will now go forward next and then create a stack, which means I need to give it a name of the stack. So here is the name of the stack. I'll call it Cloud Genius. I will choose T2 small instances. I need to select a key pair here. I have a workstation key that is already there in my Virginia area. So I will go to my virtual machine and make sure that I have the key there. So I'll just start the machine. I should have the keys, the same key. So, but you know what? It's always good to check. Always good to check these keys. So I may not have the exact same key. It may be labeled workstation, but I want to cross check. The way to cross check that is go back and go to Virginia and go to EC2 and check your key pair. And there is this workstation key pair. You want to cross check that. You want to import your key pair one more time. And I will like to do that just to double check, because I don't want to mess with keys. If the keys are wrong, I cannot access it. So here we go. We got grab our key pair and then copy the key pair, dump it here, and it is the same key. I'm happy about it. I can see it's the same key because the fingerprint is the same, which is nice. Now go back to Amazon, go to CloudFormation one more time, and grab my link from here, copy link location, and then go back to CloudFormation, create a new stack, and specify the template I want to create, which is what I'm doing right now. What I'm doing is I'm specifying this file and saying, hey, you go apply. That's what's going on here. I'm saying, hey, select my template that I gave you here and say next. And then I say, okay, give it a name. I call it Cloud Genius. I'm going to search for a key, and I have two keys. They're the same. I'll select the workstation key. I'll specify the operator email. That's my email address. I can also specify here the location where I am allowed to connect from. I can narrow it down if I like. But for right now, I leave it open because that's not the security exercise. It's the exercise about scaling automatically. So this one is not critical, but in practice, what you should do is you narrow it down to your IP address. What is my IP? And you grab your IP address from there, and that is my IP address. So I grab it and I will put it right here and then put a /32 after that. That very narrowly scopes it down to only my machine or other machines inside my location can connect to this stack that I'm creating. Stack contains resources. In this example, in this template, it contains auto-scaling group resources. Now in that SSH location, I want to actually leave it open so that you can also access it if you like, or that's the way I'm going with it. That the IP address range is open to the world, which is okay. I'm going to select a subnet. The subnet selection of my choice is going to be one of these. And so here are the subnets that I have available in a VPC that I have. These are the default VPC subnets. So I'll select any one of them. It's not that critical. Or I'll select all of them. That's also a possible scenario. So I've selected 6 subnets. You can understand what's going on here. Is that if you go to look at Amazon Web Services and go to the account in the Virginia location and you try to create a new machine, it tells you that you can launch a machine in any of the 6 availability zones, A, B, C, D, E, F. That's what's going on here. We are selecting these 6 subnets here, all the 6 subnets. The reason we are selecting these 6 subnets is because our VPC that we have in Virginia is only one, and in that VPC we have 6 subnets, A, B, C, D, E, F. And more importantly, what I want to do is to have my auto-scaling group create machines on different subnets. Not all of them on one subnet, but have multiple spread out scenario where I can have machines created in multiple subnets. That's the underlying idea behind selecting all the subnets here. And then I'm going to select my VPC ID, which is the VPC that I want to create this resources inside. So I'll select my VPC ID and then I proceed forward with the next step. So again, stack name, instance type, you can select bigger machines if you like, but that's pointless. It's just a demo. You select your key pair, you select your operator email, SSH location, subnets, and VPC ID. You provide these details to the machine, to the template, and ask CloudFormation to use the template to create resources inside this VPC in those 6 subnets. We go forward. And then they're asking us to tag, and not tagging, asking permissions, not going basically, they're choosing the default options. And I go forward with next, and then here is a summary. In the summary section, what I see is that it is telling me it is using a template. Oops. I messed up. I'll do it again quickly. I have to create a new stack and I'm going to specify that template. No, not this. A template comes from here. So copy link location and dump it here. Go forward, assign it a name, and then select a key pair, operator email, and then select all these subnets that I have and select the VPC ID, and then I proceed forward. And I am not assigning any of these default values and not changing them. I proceed forward, and then I'm going to review. I'm using the template, which is the one that I already know from the documentation. I'm using that. There is the detailed stack name, size, key pair, and a bunch of other things. And that's the summary step. I want to actually go ahead and create right now. But before that, there is this idea that I want to talk about, is the cost idea. So if you click on the cost button, it'll tell you estimated cost of what will it cost you every month if you leave the stack up and running. It'll cost you $18.94, just giving you a quick overview of what is getting created. You can expand and see what it's creating. You can see that there is a compute cost of $18.94. There's a CloudWatch cost and a support cost, mostly 0. and that's your recurring bill of $18.94. Having this as a button to understand what the cost is going to be for a template that you want to use to create a new set of resources in a cloud of your choice is a good thing to have upfront. They're telling you the cost that you will incur, and then I will now create my stack. Well, as simple as clicking the create button, and I'm beginning to create my stack of an auto scaling group, which is what you see here. It has started the creation process. The creation events will populate in the events tab, and output will show up here. So currently there is no output found, but currently the action is in progress. So you can see the events are happening. Some things have completed, other things haven't completed yet. I would like to have all these things complete, and then at that stage we will have the stack ready. What this tool is doing for us is basically looking at that template that we had our hand here. The template that we use from documentation, it is applying that design over to this cloud to construct an auto scaling group using the CloudFormation tool right now. So we can then experiment with this thing itself, and we'll exercise the auto scaling idea that we just discussed. So we are waiting for that creation to finish, and then we will go experiment with, first of all, examine what do we got, and then we will scale it, or rather create situations in which it will automatically scale by itself. I think that's the right way to say it, as opposed to scaling it by hand, which is not what I want to do. I want to create circumstances in which it should automatically scale. So I will create those. Right now it is in progress. So in the meanwhile, I'll go and review my notes about how to trigger, how to create circumstances to trigger the growth and shrinkage. So let me go to identify the steps that I am trying to refresh my memory while this thing finishes. I'm just catching up with my notes as to how do I instantiate a scenario in which hold on, where is that? Somewhere I made a note to myself. Oh, there it is. I found it. So I'll keep that handy, and I'll pass a link to you. And this thing needs to finish, so I'm going to refresh my browser. And look like creation is still in progress. So this takes time a little bit, but it will finish eventually. I hope it finishes, because this is going through their documentation to kickstart a new stack of resources called PG. That's the stack we are building, and it is getting created, creation in progress, which is good, but just do it quickly, man. Okay, maybe we should take a break, because you will otherwise see me expressing my frustration at slow clouds, which is what I should do. Just complain. Okay, these guys are, yeah, I think there's something. Let's go watch what's going on. So in our cloud in Virginia, we have something must be happening in the EC2 section. Let's see what's going on there. Oh, there's a machine running there. See that started. So something happened. That creation happened because of the template getting applied. The template is in the CloudFormation. It is applying. Oh, create complete. Nice. The whole thing is created, which is good to know. Good to know. And I am thankful for Amazon to completing the creation step. Now it is my turn to exercise what I call a situation that will trigger automatic scaling. That's what I want to discuss with you now. So let us go first of all find out what did it do, like what is created. So let's go examine. It did something for us. So we can see that there is this machine called T2 small created, and it is running and currently initializing and all that good stuff. It is on the VPC. It uses the workstation key pair. It has the inbound rules, allows me to connect from SSH. Nice. What else we have? We have a public IP address there. We copy that. And we have a load balancer. The load balancer is created. Behind this load balancer are the machines auto scaling group set already. And in that load balancer, there is a listener. And that listener is listening for the activity coming from the machine on the back end. Which means if you go look at the target group, that is the load balancer targeting, you will see that the targets contain one machine, which is this one, and that machine is healthy. That means we can actually see our load balancer, and we can go to that IP address, which is this IP address, by the way, the DNS name, and help you understand this thing idea. A little bit complicated, so let me help you understand this. So you see that this is a name for an A record for a DNS for our load balancer, and it has a listener that is targeting a target group in which you saw that there is a machine running and healthy. So what is this whole thing? The whole thing is basically there is a load balancer, elastic load balancer, which is what this thing is. And you and me can visit the load balancer. The load balancer itself is currently forwarding traffic to one machine. That machine was the one that is healthy, that you saw early on in my EC2 segment. That's it. That's the design we have. So users can come here and they will be diverted to that one machine. That's the only machine we have. We have 6 subnets. 5 of them are unoccupied. This machine is sitting on one of the subnets. There are 2, 3, 4, 5, and 6 subnets are unused. There's nothing there because there's no machine active. Only one of the subnets has one machine active. That is this. Healthy, running. That's the design. Now what I want to do is create a situation in which that one machine is not enough to handle this load. Now it is you and me and a bunch of other people. Even if we hit this load balancer, this one machine can just comfortably handle the load. No issues, no problems, and it will never scale out like that until we get like 100, maybe 1,000 people. You have to get 1,000 people here to hit the box on the load balancer, and everybody goes here, 1,000 of them. It might at that time actually create one more machine. It's very hard to create a scenario like that. You have to get 1,000 people. How can you get 1,000 people on a dumb, stupid idea like this? Nobody's going to visit that website. So you're not likely to see the scenario jump with the creation of one more machine. Very, very impossible. Practically impossible. But nothing is impossible when you have tools at hand. So we'll bring fake people and load up the machine. That's what I'm doing basically. I'm going to create load on this machine. Simulate. Or actually put real load on that machine. So it will bring that machine down to its knees. And it will start to crawl. And when it crawls, you will see that your auto scaling group will take a note that this machine is at its knees. So it will create one more machine in another subnet. And that becomes a part of the elastic load balancer. And thereby, you're dividing the load of incoming traffic into 2 parts. So the people visit lots of visits. You're dividing them into 1 and 2 parts, 2 machines, 2 subnets divided. And thereby, both of these machines are basically spreading the load. So this machine is not on its knees anymore. They're running nicely. This is also running nicely. And you get more people, lots more visits. So you will see that both these machines are on their knees. So that time something will trigger, and then you'll see another machine. So now I will like to show you what the triggers are and what the auto scaling groups are going to do. So I'm going to erase my drawing right now. So the red ink will disappear. And I will now switch over to the healthy machine that I mentioned in the target group. In that target group, we had one target, which is this machine. It is currently healthy. And that machine itself is in the EC2 cloud. It is now 2 of 2 checks complete. And that's the IP address. And I copied it. And I'm going to go to that IP address right here and say, hello. Is that the Ubuntu machine or what? No, it's the Amazon AMI machine. So it is not Ubuntu. So the username is not Ubuntu, but that's the username for Amazon machines. So just understand that. So I'm going to say yes, and I'm connected to that machine inside, right there. This machine. This machine is the one that is behind my load balancer 1. That's where I'm connected right now. And I will bring this machine to its knees. That's easy to do. I'll show you how. But when it goes to its knees, then this auto scaling group will notice that the machine is dying. So I'm going to now clear this ink again, red ink. Red ink goes away. And I'll go to the auto scaling section to see what we have there. We have an auto scaling group configured. And that auto scaling group has a bunch of scaling policies. There is a policy here called down policy. There's a policy here called up policy. We'll understand these policies later. But let's see what else we have. We have a launch configuration. This launch configuration specifies the type of machine, the operating system, the exact thing that you want to see when you have a new machine to be created. Use this template to create one more. And that is the launch configuration that you have here. That's the model that you use to create one more box. Now, in our ASG, as you notice, and also our load balancer, as you notice, that there is this public facing IP address, which is this record, which I just copied. That is also available to you in the Amazon Cloud Former tool as an output in the creation step here. You see that it gives you a URL, which is this URL. And if you click on that URL, you just see that you successfully launched some Amazon blah, blah, blah. That's what the website is showing you, because you are visiting a load balancer. The load balancer you are hitting here, it is transporting your traffic out to the machine that you have running here, which I am connected to, by the way. I am SSHing into that machine. And that is what is showing you this view. You're visiting here through the load balancer. It is transporting your request over to that machine. The machine is doing happy and healthy, and it's not on its knees yet, but now I will put it on its knees, meaning it will start to cry, complain, and you will see how it cries. Let's go see that. So the way to make a machine cry is to throw a load at it, really heavy load. Let's go see how do you put load on it. I have a cheat sheet for that. The load is right there. So I will now take that sheet and apply. And you will see what do I intend to do is I'm going to stress out that machine right now. That machine is the machine that I am connected to here. This one that I'm looking at. And I'm going to do something exotic. What am I planning to do? Is I'm going to install a tool called Stress. And then I'm going to run some stress. And I'll give it a timeout of 660 seconds. That's a carefully chosen number. Because what I know about our system is that we want to stress this thing out for a period of how much time? 11 minutes. Is it 11 minutes? 60 seconds, 10 minutes, 11 minutes, yeah, roughly 11 minutes. So I'm stressing out that machine. First install stress and then stress the heck out of that machine for 11 minutes. So for 11 minutes, this machine will cry and complain as if it is dying. And you will see what I mean by that by opening one more window. So here, opening one more window of the same type. SSH EC2 user at the IP address. No, where's the IP address? At 54.165.8.2. This is another window. And there I am going to install a tool, another tool to inspect what's going on, right? The inspection. The tool is called HTOP. Don't have it. So install the tool first to examine what's going on. So you sudo yum install htop, should install the tool, and it says, yeah, go ahead and do it. So the htop is now running. So we can see that the CPU consumption right now is 0%. There's nothing going on here. It's close to 0% CPU consumption. Okay, now watch this window. We'll keep it open on the side and stress out. Oops. Keep it open on the side here, on the right side, and on the left half, I will now stress out the machine. So here we go, run it now, install stress, and then run stress for 11 minutes straight. Right now, let's check the time. The time is 18:29, right? So about 6:30 p.m. Pacific, 18:29. I will now note the time and run stress. So it is saying, are you sure you install stress? And I say, yeah, go ahead, install it. And so it says unrecognized option CPU. Fine, there's a typo. The typo I need to correct is that this option is actually -- CPU, copy paste error. So you say -- CPU and then run it. Now the typo, another one typo is the timeout typo. It should be -- typo, -- When you copy paste from a website onto a command line, you typically run into these kind of problems. So it is now doing it. You can see it, the HTOP showing 100% CPU. It has dispatched hogs, 2 CPU hogs dispatched. And the CPU is 100%. You can see that the CPU is 2 hogs are running close to 50% each. And they are basically bringing the machine down. The time we started this hogging is at 18:31. So in the next 11 minutes, you will see that something is going to happen. And we'll leave this running. And I will now switch to examine what? Let me first erase my ink. So ink erased. Then I will examine the machine from Amazon's perspective. And so we'll go to the machine itself. Look at the EC2 machine. There is one running instance. And the machine is showing us some monitoring because the cloud formation actually configures some monitoring for us. You can see that for the last hour of metrics collected on this machine, you can see that the CPU percent consumption has suddenly jumped in the last couple of minutes. CPU utilization has jumped. These things are all down. It's only a CPU hog. The stress is mostly CPU related. And that's what I'm doing is I'm bumping this line up all the way to 100%. So you will see when I refresh it that the CloudWatch monitoring will show that it is close to 100%. So I'm going to refresh now. And go check the monitoring tab, and you see that the percentage showing in the CPU utilization is a slightly delayed metric. The real-time metric is available to us in here, and you notice that this is already 100 for so long now, is that it is actually hogging the CPU because we installed stress. That's going on since 6:31 p.m. Pacific time. So it has been, what, 2 minutes now? So in the next 10 minutes, we expect something to happen. Now let us understand what is expected to happen, and we'll actually see whether it actually happens or not. So we will now erase the red ink one more time. And then leave this one running, go back to the other side, refresh our metrics to see if this catches a little better. We like to see CPU utilization at 100% in the graph. In the monitoring tab, it is showing a little bit better than 100, better than 50 right now. But I think these are a little bit older metrics, which is what you already understand. Having seen this, let us also go and now see the auto scaling group, in which we want to focus on the policies that are put in place. So now let us go read the triggers corresponding to our scaling policy. And this is cryptic to read, so I'll help you read that. There are two policies here. One policy is the up policy, the other is the down policy. In my way of describing these things, I call this the shrink policy. And this is my grow policy. So let's go first look at the grow policy. The policy type is simple scaling. It is this name that is assigned to the policy, which I call the grow policy. What it's supposed to do is add one machine. But when do you add that one machine? You add that one machine when this thing happens. What do? You take this action. What is that action? Add one instance, like that. And then you do something. So there's a when condition, there's an action, and there's another condition, another thing to do after that. So let's go understand what is the action. Action is clear. That part is done. Add one machine. And then wait for, that's also something to understand. It's a very important thing here. But let's go read this when section. When do you grow? You grow when this policy, no, this is not policy, this is the alarm, high. Let's go read that. It is a alarm called high, which means it is actually a measurement from monitoring. CPU alarm high. That's a CPU alert coming from the monitoring side. It is monitoring the CPU, just like I am monitoring the CPU in a edge top, like that. Same thing, except Amazon will monitor using the Amazon CloudWatch service. So there is a service here called CloudWatch. That's where these monitoring tabs pop up. So you're looking at the graph picture I was showing you before. That's where the triggers come from. CPU alarm high. It is going to notice soon that the CPU is pegged 100% since 6:31 p.m. And it is 100% for so long. It is 16:37 for the last 7 minutes. It is 100%. So let's go read further. So that's the trigger. It is going to notify this auto scaling group that the CPU alarm high is triggering. When it breaches the alarm threshold, meaning the breach condition is you have to have the CPU utilization go more than 90. Well, we are at 100. And so for 2 consecutive periods of 300 seconds each, that means 2 periods of 5 minutes each. If you have 5 minutes of 100% and then 5 minutes of 100% again, CPU consumption, if that thing happens, 2 consecutive periods of 5 minutes of 100% CPU, if that happens, for this metric dimension, which is the one we're talking about, CPU alarm high, that's when you execute the policy. So when you have 2 5-minute windows of 100% CPU, or rather I should say more than 90% CPU, more than 90% CPU, when it is more than 90% for 2 consecutive periods of 5 minutes each, we know we are at 100 because we are hogging. You can see it, we are still hogging. And that's okay. I mean, that's a necessary condition. But that's the reason when it triggers this policy. And when it does trigger, you know what happens. And that should happen in the next minute or so, because it has been roughly about 8 minutes now, 1839. So it's about 8 or 9 minutes that we notice that this has happened. This CPU threshold has breached, meaning it is more than 90 for about 9 minutes now, which is about to meet the when condition. So I'm going to now erase my red colored ink. The ink goes away now. So this when condition is going to breach soon, as you know already, because this CPU utilization more than 90 for 2 consecutive periods of 5 minutes each is about to happen, which means we should see that our EC2 dashboard has one more instance created. You should see that. We are not seeing it, but that is just because I am being impatient. You will see it. The trigger is almost happening at 1840 right now, and we started at 1630, what, around 1831, I think. So it's close to about 10 minutes of period, and that's when you will see a new machine pop up, because this one is dying. It is at its knees with 100% CPU. You can see the monitoring tab, and it shows you right there, showing you in detail for the last minute by minute detail. Let's go see what it shows. It shows that the CPU reached 100% at this time. This time is something after 2:30. This is the UTC time, Universal Time Coordinate London time, and it has been high, 100%, for a period of 2 consecutive periods of 5 minutes each. Is that the case? Almost, but not exactly. So that is what we need to refresh and wait for the trigger to trigger. And when it does, you will see another machine right here with an ID number, another T2 small, all of that you should see soon. And you just have to be patient with this. And there's nothing wrong with, actually, everything wrong with being patient, because I'm not patient. But I should just stop and learn to be patient. So let's see, this refreshes. Is it crossing to 10 minutes? Not according to the graph. What is the time right now here? It is 2:40 according to this chart, and at this chart is 2:31. Okay, so 2:31.
My
Yeah.
second one is spinning up.
Oh, you're doing it? Awesome. Awesome.
Try refreshing
Beautiful.
yours.
I'm very happy. I'm very happy to see that. Why don't you show it to me? I'm going to stop projecting and you
Did
show
you
me.
refresh? Oh, it didn't work for you? Oh, that's weird. Okay. Yeah, let me show.
It is not working for me yet because I am getting impatient, nothing more. Yeah, see that triggered? It triggered for you.
Yeah.
And so that is triggering. It is, it's not triggering, it has triggered already. And so, yeah, that's a good thing. Now that it has triggered, I would like to show you the next idea, which has not triggered for me yet, but yeah, whatever. I'm going to annotate the screen right now.
Okay.
I'll talk a little bit about what's going on. So this one is initializing. And so now is a good time for you to take this down to 0. I mean, what I want to do is to do the opposite. I want to now exercise the shrink policy. Right now, you successfully exercise the grow policy, right? So you have this new machine created, this one created, it grows because your CPU was 100% for more than 2 consecutive periods of 5 minutes each. So it grows. It grew this machine in a different availability zone, which is fine. All of that is good. Now what I want you to do is go to the second part of the exercise. The second part of the exercise is to somehow shrink automatically. And I want you to shrink. The automatic shrink policy should trigger when, let's go see that. So I'll now request for remote control a little bit.
Is it in here? Oh.
No, I will ask for it. I'll ask for it. And so what I will now do is, where is that? Can you help me go back to the Amazon thingy?
Oh.
The AWS thingy?
Let me get in here. Sorry.
Yeah, there. So here what I want to do is go look at your policy. Oh, I'm still annotating to clear. So go look at the policy. Where is that? Auto scaling groups. And there I want to look at the policy to shrink. So here is your scaling policy. And we'll go and look at the shrink policy, which is the down policy. This is your down. And you know what it does? Down policy. Let's go see what it does, see what it reads. So where is my annotation tool? Apparently my annotations, they're back here. So the down policy executes when the alarm low CPU utilization is less than 70% for 2 consecutive periods of 300 seconds. So 2 times 5 minutes, the CPU utilization should be less than 70. You can very easily accomplish that by killing your hog process, the CPU hog, right? Very easy to do. So what I'm doing now is clearing my drawing and then going to the machine here. And you have the hog running somewhere. The hog is successfully completed already, by the way. See, 660 seconds. The hog finished. Dispatching hogs. Hogs finished. Nice. That means your next policy condition will trigger automatically because the CPU is not on its knees anymore. You have 2 machines and you have the second one, or the first one, and its CPU has gone down because the hog finished. Hog was supposed to run for how much long? 660. It was supposed to run for 11 minutes. So it finished. So it is now 0 or close to 0 right now, which means in the next 9 or 8 minutes approximately, you should see the other policy also trigger and it will end up killing one of the machines. You will see one of the machines will automatically die. Other one you have to eventually kill yourself, and I don't kill it by hand. I'll tell you how to kill. This is a special way to clean up. So I'll tell you about that later. Don't kill these things by hand. we'll use automation to kill. And so you have to wait for this time for the second one, for the, what is the word? Shrink policy, for the shrink policy to trigger in this amount of time, maybe 7 minutes now, for it to trigger. And when it triggers, it will kill one of these guys. You don't know which one, but it will kill one. And that's what you will see when it kills. So that killing action should happen whenever it does, should be in the next 7 minutes. So let's see what is going on my screen. Is it running for me or not? Let me just quickly check. I am still on your screen, but I'm going to see my screen as to what's going on. And is it even doing anything? Oh yeah, it did, even for me. So that's me being impatient, nothing else. So I am going to now project my screen and show you what I'm seeing. Here it goes. You see the same thing. I have 2 machines now, and I will now go to the segment where I have auto scaling groups, and that's where you will see some interesting insights to read. See the scaling policy we saw, that we used this up policy before. Actually, the machine set automatically used the up policy. We didn't use it. But there is something interesting to read now that we have the policy threshold breach. This breach happened when it was more than 90 for 10 minutes. So as a consequence, there is an activity history. And let us go see what that activity histories are. There are 2 of them. And let's go read that very carefully. It is again very cryptic to read, so I'll read it for you. First time it is cryptic, next time you will understand it easily. But let's go see the first one. Which is the older one? This or that? This is the older one. So let's go read this one first. It started at 1815, so the older one. This is 1841. So read this now. Launching a new EC2 instance. Description, launching a new instance, this one, fine, because at this time, a user request update of auto scaling group constraint from a minimum of 1, maximum of 3, desired of 1, the min, max, desired, 3 values, min, max, and desired of 1. Changing the desired capacity from 0 to 1. So the earlier desired capacity was 0. Now the desired capacity is 1. The minimum is 1, the maximum is 3. So this change happened. Basically, this means that you applied a new template. You set up auto scaling group to begin with. In that duration, when you did, you basically transitioned like this, 0 to 1. I now want 1 machine. And so it created your first machine. That's this one. Then at some point, something else happened. And that happened because a monitor alarm came along that triggered the policy called up policy. And that launched a new instance. This is a different machine. This is the first machine. This second machine was launched with the up policy because changing the desired capacity from 1 to 2. So now it is 1 to 2 desired capacity. It is growing like that, 1 to 2. So the desire increased. You increase your desire to 2 because of the alarm that triggered. And so it increased the capacity from 1 to 2 because that's what you mean, your desire. So it is implementing your desire on the fly, based on triggers. So that's the 2 events that have happened in the activity history. Now, in the next 2 or 3 minutes, you will see a third event happen in which you will see successful delete an existing instance, something like that, because a shrink policy triggers. So by the way, shrink is my word. These guys call it down policy or whatever, doesn't matter. words are immaterial as long as you understand what's going on. So this auto scaling group, as you saw, the scaling policy, as you know, this is the policy called, what is it called? Down policy. And so that will eventually trigger in the next 1 or 2 minutes, and you will see a remove instance action. So you will see now whether it's happening or not. So see that there are 2 machines running, and one of them is going to die pretty soon, as long as I'm being patient. And so let's see when it dies. There's nothing to do here. That's the hard part.
I have a third warning now if you want to show my screen.
Awesome.
Or I will share my screen.
Yes, please. Yes, please.
So I see the third one, but I don't see it doing anything yet. Oh, I don't want to do that. So
Yeah, it will. So it is doing it. You can actually read it. And so let's go read that. I am going to annotate on the screen. Can you make it full screen a little bit?
Sure.
So here you can see it is waiting for ELB connection draining. This connection draining is basically you have load balancer and it has 1 or 2 machines, the first one, the second one, and now it is going to kill one of the guys, but it has to drain the connection and then kill this guy. You know, you have to let the load balancer know that you are about to shoot one of the cows. Otherwise, if you just shoot the cow and have the connection established, you have a customer visiting, they will be directed to that dead machine. You don't want that bad experience, so you have to drain the connection. Drain the connection before you shoot the cow. That's what's going on. It is going to terminate the instance, waiting for the draining to happen. When the drain happens, you will basically take all these customers who are hitting this machine at that moment, you will have them redirect to the other location, then you drain out this line, and then you take a gun and shoot the cow. And so that's what you're looking at right now, is the drainage happening. And I'm going to clear my drawings again. And now you can refresh the screen to see the next action, or probably in the same action, it will just refresh. It is in progress. So let's go see. It is terminating. Now what you can see is, I think the termination is happening right now. So instances should be 1 is dead. You should see one of them is dead. Yeah, shutting down, and it will eventually get terminated.
Okay, looks like it worked.
Yeah, it did. So let's go back to our auto scaling group section and read up on the event activity, which is activity history, and it should be in progress, and it should actually say that I am terminating or I have terminated or something like that. I think it is currently saying it is terminating. So the terminating action is what's going on. So when it finishes the termination, it will say terminated. Right now, it is saying I'm doing it in progress. So you can see that the same idea here, alarm low, alarm triggered, this policy called down policy, because the desired capacity go 2 to 1. This change happened. So an instance was taken out of service in response to a difference between the desired and actual capacity. See, the desire and actual, they have to match. If your desire changes to 3, then you have to grow the actual to 3. If your desire goes down to 2, you have to shoot one machine down and make the actual equal to desire. The actual needs to match what you desire. So your desire can change dynamically on a policy, on a trigger, or maybe on your application or design or your injection of something. You want something, it needs to do it. That's as simple as that. You have a desire, it implements. Your desire changes, it implements by shooting. Your desire changes to 4, it grows. That's a very simple idea to think about. So it is your desire, nobody else's. Let's refresh, and it should have been killed by now. So completely, it should be saying terminated, successful, terminated. So it's done. Our exercise is done. Now let us walk you through how do you clean up after the whole thing is the whole cloud formation. Like, so I'm going to request for remote control and take you to the, where is that? Cloud formation. Here, cloud formation. And there is your creation process that you did this creation step using that tool called Cloud Former. So I don't want you to terminate machines on your own on the outside of the tool, because this dictates what's going on. Even if you go outside and try to kill something, like for example, you go to the Amazon cloud and you go here and say, hey, I have that machine out there, this one. I don't like it anymore. I'm done with my exercise. Let me just kill it. So here you go. You say, I am going to kill. And you say, bye-bye. Now you think you killed the machine, right? You think. But see what happens. Just wait for it. You think you killed the machine, and yes, it is going to die, no doubt about it. But wait for it to happen. Because what will happen is, go to AWS, go to Cloud Formation, and you see this guy is in control, right? So as a matter of fact, it has put together a auto scaling group for you, right? And the auto scaling group has a desire for one machine right now. How many machines you actually have? 0. As a consequence, when it detects that you killed the machine by yourself, then it will start a new machine, just like it did the very first time. 0 to 1. In response to your killing, it will create a new machine. It will keep it at one machine until the CPU percentages grow to more than 90 for 2 consecutive periods of 5 minutes each, in which case it will go to 3. But it will eventually detect that something went wrong with your machine, so it will generate another one. You killed it yourself, doesn't matter. And so that 0 instance is running, it will eventually detect that there's no machine there. And so it will start one. And you will get confused. I thought I killed the machine and it came back again. What's going on? That might happen. So the proper way to clean up is not go do it manually, but go the way you created it. And there you say, here, you please delete my entire stack. And by doing that, you not only delete the machine, but also deleting your auto scaling group, your load balancer, everything else will go along away with it. Now delete is in progress. This will guarantee killing every single thing it created. In the past, it created so many things. Now it is deleting every single thing. You can see that create complete happened in the past. And then this was done, by the way, at that time, whatever, the 1817. And so this 19 is what right now, is it?
Mm-hmm.
Yeah. So 19 at 19, which is right now, deletion action started and all these are delete actions going on. So the deletion will successfully complete. And at that time, you can get rid of it. Delete the stack and the whole thing will disappear. And that will take care of every other resource created elsewhere in the cloud. So here, this machine, that load balancer, they will all start to die because it's going to be killed now, this one. There is a target group and a target group has a target that we killed manually. And so there are no targets. That's fine. But even this group itself will die. So all the things that we did in the exercise today, they will all of them together disappear collectively. That's the idea. So don't kill this by hand because you cannot actually kill it. It will come back to life because of cloud formation. No, not because of cloud form. Because of auto scaling group, it will come back to life. If here, if you don't delete like this, you might have a trace of something that you leave behind, and you may not be aware of something left behind, and it might cause a bill. Just telling you that. It might generate a bill. You don't know. If you don't know what you're creating unless you know what you're doing, then it's okay. But if you're like randomly using some random templates and then applying them, and they will create a bunch of resources. So just be careful. And before you take a template available out there from somewhere on the internet, on Amazon documentation, just make sure that you understand what it is going to create, and then of course go and play with it. Do absolutely play around, experiment with a bunch of things, find out what it is doing, destroy the template, destroy the formation after you're done, like just like this, delete in progress. That action has to finish, and you can see the actions finishing up here. And when it does, then you feel happy about it. And then you say goodbye to that template. But of course, go experiment with these things. Absolutely do.
Okay, cool.
And I will check the same thing on my side, probably the same way. What's the time? Right? Oh, already shot out. We already shot beyond the time window. So next time we'll do more exercises, and then maybe also do the, what is it called? These pictures discussions. But I want to understand, I don't want to bore you with things that you don't want. So if you say that you want, anytime you feel that, too much of discussion, let's go to hands-on, we'll just switch. I have enough of both. So, there's no shortage of stuff. You need to pick and choose. We have only 3 more sessions left, which is crazy how fast it goes. And so right now it's November 9th. So next week we are done, which is wow. So I want to point out one more thing before you go, is that the Bellevue College has set out cloud computing dates for the next set of boot camp. So here you see that there are next set of boot camps already announced, the cloud boot camp and the machine learning boot camp. Both of them are announced. They are going to be running on these dates, like 21st of January starts and goes all the way through 15th of March. That's the cloud boot camp. And the same similar dates for the other boot camp are 22nd of January through 14th of March. And that's the machine learning AI boot camp. And I would like you to please tell your friends and coworkers in your company that this is happening. And one more thing, how are you finding the boot camp? Is it useful for you? That's the real question to ask. So I'm asking you, what do you think? What are we doing? How are we doing? Is it useful?
Yes, very.
Yeah, it's been really useful.
Thank you. So please tell your coworkers who have not taken the boot camp about these two, and ask them to sign up. Bellevue College is open for registration, so you can just follow the same process like you did, call them and register, and have them register. So thank you very much for your help. This is how I have been successful in running the program, by making sure that you actually enjoy it. So the reason I run it like this is very, very different from any other program you may have seen before. Is there's a boring professor who talks and puts you to sleep and all that. I try not to do that. At least I hope that I'm not doing that. That's my best hope. So I hope I'm succeeding. And I think I am succeeding for the last 5 years, but I want to continue to succeed with your help. So please tell your friends, coworkers in your company. Thank you.
Will do.
All right. Thanks, Nilesh.
Bye.
Thank
Enjoy
you.
your weekend.
Have a good weekend. Bye.
You too. Bye-bye.
Bye.